Hello, everyone, and welcome to today's CDCT Live. I'm Jason Rader. I'll be your host as we talk about DNS vulnerabilities and how to secure them. I've got two experts with me that are going to help me in the conversation today. We have Tunde Odele, who's the leader of our security testing and assessment practice, and Victor Aranda, principal security architect and competency lead for security operations and tools. Good morning, gentlemen.
Morning, Jason.
Good morning.
So why don't we just kick this off a little bit with you guys telling us a little bit about what you do at Insight here with me. Victor, why don't you go first?
Well, what I do is typically network-based controls, but although it really ranges, and that's on-premises to in the cloud, everything from firewalls to cloud posture assessment and cloud workload management, all sorts of things. So at Insight, I do a combination of consulting with clients and helping with projects and escalations and things that need a little bit of extra hands, and internal training, product, practice development, vendor, and partner management, and building those bridges and so on.
Nice. So I should have said, what don't you do at Insight? Probably. Awesome. Tunde, why don't you go?
Yeah, and obviously Victor and I are in the same team, so kind of do the same thing, but I focus more on the security and testing practice. So the run-of-the-mill stuff, vulnerability assessments, penetration testing, the more advanced stuff, red team, blue team, ransomware simulations, all that kind of stuff. So I kind of focus on that. We do a whole bunch of remediation as well, solution architecting around threat management, which is obviously part of the reason for this conversation. We assist customers with a lot of pre or post sales type discussions around strategy. How do you remediate or deal with issues, or after the fact? We've got an outbreak, we've got a breach, whatever that might be. So kind of play both sides of the fence. So look forward to the conversation.
Yeah. And again, so qualified folks on the phone related to the conversation we want to have about DNS. And I think, to Tunde's point, we do the proactive and the reactive stuff. Way better to have a proactive conversation with somebody rather than the reactive conversation. And thus us talking about this particular DNS vulnerability that was brought up at Black Hat. And before we get started, for the uninitiated, I mean, DNS used to be like the center of my world at a certain point in my career, but now we don't really think about it too much. Let's remind folks up there why DNS is important, what it does for us. Victor, you probably got a Wikipedia article up about it right now.
Yeah, hold on, let me read this. For those of you who are, most people are aware, at least vaguely, what DNS does, but it translates a name that you're comfortable with, typing into a browser, or something that might be programmed into an application or something, to an IP address or IP addresses, and allows your computer to. That's my dog. I knew that it was going to happen as soon as I came off of mute. Hold on a second. All right. But yeah, it translates to IP addresses that your computer can then make a request to, and then it goes way, 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 way complicated once you start getting into the gritty.
Yeah.
And from that perspective, it's saving us from typing, HTTPS colon 192.168.1 dot something, and instead we get to type www.google.com and go somewhere. So, but a lot of people take that for granted because we just type those names in, really not even thinking about the fact that something on the back end's resolving it. And when you've got resources in your own organization, as we all do, DNS is what helps those guys resolve for different services and things on the local net as well, which is kind of the point of the vulnerability that's kind of popped up. And so, Tunde, why don't you kind of roll us through what was discussed at Black Hat recently?
Yeah, so this is actually a presentation at Black Hat by a company called Wiz. I believe the presentation was done by their CTO. So they had an interesting proof of concept that they put out there. Specifically, what they looked at was managed DNS as a service providers, right? Was the target of this analysis. What they found, long and short of it, was by registering certain types of special named domains, you could literally redirect all the DNS queries and traffic going to one of these servers hosted by, in this case, they actually tested Route 3 for Amazon and Google DNS. You could literally redirect all the queries going to one of the servers to the attacker servers. And they actually showed this in real time, and it was actually phenomenal. It actually did work, right? It kind of exploited a flaw. And the simple flaw really was you could, so for example, let's just say an Amazon DNS server is www.awsdns.com or .net, for example. You could literally register that as a domain name. You could register a server name as a domain name. Now, my understanding is it's been fixed, but who knows? It might actually be out there with some other DNS service providers. By doing that, which is actually very ingenious, any servers or any systems, and you could think about the millions of devices that are out there, all querying whether Google DNS or whatever, again, being provided as a managed service, anything reaching those servers, all of a sudden there's this record that says, oh, you need to go talk to this guy over here. And now the attacker can pretty much see all the DNS queries for that environment. Well, what does that mean? We're talking about host names. We're talking about user identities. We're talking about services. I mean, there's a plethora of information that you can harvest from DNS queries. If we look at some of the exploits that are typically leveraged even in the attack world, a lot of the credential dumping type of stuff, they leverage name spoofing, address spoofing and stuff. So you kind of have that same situation. So in the proof of concept that these guys actually showed, which is actually quite ingenious, they could literally geomap several companies, right? Companies that were operating, for example, in regions where they were not supposed to operate, right? They showed an example where I think there was I'm going to name, there was a certain company that is bound by U.S. Export laws, but then they had users working out of Tehran and God knows where else on the planet. So
we hope they were users.
So that's exactly right. Who knows? So that was really the proof of concept that was put out there, and it kind of highlighted the fact that a lot of organizations just spin up DNS. They just point DNS traffic without giving it a second thought, right? And Victor and I were just discussing earlier. There's all sorts of attack vectors that you can even leverage DNS for, right? I mean, there are tunneling applications that will actually tunnel data over DNS for that very reason. And remember, it's a legacy protocol. It's been out for how many years now? It hasn't been any. I mean, we've got DNS security and stuff, but nobody's really paying attention to it. So
no, that's brilliant. And I think one of the things that I wanted to bring up, not only do we query DNS for information, but especially on a Microsoft platforms that really rely on dynamic DNS name registrations and service registrations, I can set up a DNS server and then everybody tells me who they are and what they offer, which lets me map your entire organization.
That's exactly right.
And that's where those like Tehran things were showing up and things like that. So, I mean, you could really wreak a huge amount of havoc. And what's interesting is people will start to try to investigate this. They'll only look locally. They won't think DNS is the problem because it's one of those things that's kind of out of mind, out of sight.
Exactly.
There's a wonderful haiku. I didn't write it, but it goes like this.
I've never heard somebody lead with that.
There's not DNS. It can't be DNS. It was DNS. It's like one of the troubleshooting haikus.
That is awesome.
One of my favorites.
Yeah.
Dude, I'm going to remember that. And that you're totally right, because I mean, and I used to say this, name resolution is like so important. People don't realize how important that is to their organization until it busts, until they stand up something new and they lose access or make a system on theirs root that, it never goes out to anything else. There's all kinds of things that could really mess with it. Let's talk about the tunneling and DNS, because I think a lot of folks, especially if they're using external DNS services, they'll leave certain ports that DNS uses open thinking, well, logically, people are only going to use that for the appropriate DNS queries.
Yeah. And that's, I'm glad you brought that up, because it's not just DNS. There's several protocols that we would typically leave out there. Now, most people pay attention to web content filtering and stuff like that for URL. Everyone's got that down. But how many times have you heard anyone putting up some sort of a DNS proxy, right? Because like any protocol, it can be leveraged for anything, right? So in this situation, you mentioned tunneling. There are actual, I mean, from an attacker perspective, we can actually use DNS to build full tunnels during an exploit where you could block everything on the planet, right? By all means do, but as long as that DNS traffic over UDP 443 is open outbound, it's still a full tunnel. It can be leveraged just like any regular IPsec VPN tunnel can be leveraged. So it is a viable threat vector for any organization. The funny thing is most firewalls out there have some sort of DNS proxy available, but most people just never use it, right? And
they're afraid to break it.
Exactly. And then there's the other half of that is, and for years, Microsoft has had this guidance around how you should do DNS for the business. And most people have just forgotten that and just pointing DNS all over the place without, again, to your point, thinking about it. What are the risks that this provides to the business? So
yeah, after Black Hat,
where your devices are resolving their destination. So ideally, you have an on-premises or some kind of internally controlled, DNS server or servers. And then
split DNS.
Yeah, those query out to the internet, and you don't let unless it's a guest network or something, the individual hosts reach out to the internet to some random server, where things are going. And which your recursive lookups are going from your servers if they don't know about something out to the internet, but not from your campus or from your remote users.
Yeah, I was going to say after Black Hat, when Microsoft was kind of asked about the vulnerability or the perceived vulnerability, they're like, it's not a vulnerability, it's a misconfiguration. That's
exactly right.
the statement.
Yeah, it's not a vulnerability if you crash your car into the side of the road. That's just
this car's vulnerable.
Yeah.
And I think in the again, why people don't use split DNS or some of these other things is because it's hard. They've got to kind of architect kind of their naming and their strategy with this, which again, most of the times when they're about to go to something new, I mean, Active Directory was an example way back in the day where people were going to this, and that dynamic DNS aspect came really important. They had to rethink that, but oftentimes in the pure, blood, sweat, and tears of operations, we're like, no, whatever gets us done the quickest and doesn't disrupt anything else. And that's
we'll fix it in post. We'll fix it in post.
And unfortunately, DNS just presents a swath of attack vectors. I mean, everything from spoofing to man in the middle to tunneling. I mean, the list is endless.
Cache poisoning, all day long.
Exactly.
Yeah, there's also the privacy concerns too. It's not just that they can be used for attacks. It's who can see your query. So when you're sitting at home and you're not on a VPN or something, every device on your home network, regardless of what website you go to, is sending that query out to probably your ISP, which then you can see, okay, well, Jason's going to Amazon.com.
Today is the greatest.com.
I know.
Greatest.com.
Yeah.
Let me go register that real quick.
But people literally don't realize that your DNS queries are going somewhere else, and I could just totally catalog that and resolve it
in plain text for the most part. Which is a concern. So one of the things that you'll see some of the users or network engineers, people who are troubleshooting corporate networks might have seen things like DOH and DNS over HTTPS or DOT, DNS over TLS, and then there's also the other side with the server called oblivious DNS, where it won't even know who is querying for that entry, and those things kind of enhance the privacy of where you're going, but then they also introduce an element of control complexity, because now your endpoints, your iPhones, for example, Apple's one of the trailblazers there, might be making queries that you don't even get to see the content of unless you're breaking TLS.
And the whole distributed nature of DNS is another thing that is ripe for pwning, because you control your namespace, but you're usually not going to your namespace if you're going to somewhere external to the organization. So if I can trick your DNS server into thinking my DNS server is authoritative for the name that you're requesting, I give you whatever IP address, and you're never going to check it again.
Exactly.
You're only going to go to the place that I told you to go. So, and there's been standards since the 90s. We were talking about this before the show, that have existed that would make that more secure. The problem is governments and providers would have to cooperate internationally to make that, and that has been a problem since the beginning of time.
Absolutely.
But that's where we kind of sit with this. So there's a privacy issue, there's an ownership issue. I mean, it's just crazy. So
it's like any open standard, right? It's a gray area when you have a protocol that's built on an open standard. That's just the nature of it.
That everybody relies on.
There's several working groups too. I think IEEE, IETF have a couple of working groups. There's DNS security working groups and encryption working groups, and so they're all working towards something. But there's several multiple streams, and hopefully we get to a place where there's common adoption. But right now it's split between different ideas, different vendors, different manufacturers. By the way, Jason, ripe for pwning. It's the first time I've heard anything that starts with RFP that made me laugh and smile.
That's the new acronym.
Yes.
Sorry, the nerd in me is coming out. I'm supposed to be like all serious during these,
Nope.
but I think this is one of those things that gets me excited because it's just abstract to most organizations. They really just rely on this. So that being said, what should people be looking for? What are some of the ways that they need to think about from a security perspective? Victor, you mentioned from a privacy perspective, DNS over HTTPS or TLS, but literally that makes the inspection of those way harder for an organization. Talk about proxies, DNS proxies and split DNS. What about those things?
You want to have at least one device or service in that's able to discern a good from a bad DNS lookup, and that's pretty common. It's almost table stakes now in the firewall world. And then there's some dedicated services. OpenDNS was acquired by Cisco, turned into Umbrella. Different services like that, which effectively what you're trying to do is you're trying to intercept a request that some machine is probably unknowingly looking up a malicious domain that is going to be used to pwn them because they're ripe for pwning. And the request is, let's say the system knows this is a bad entry. Either we've known about it from before, we found out about it one way or another. Nowadays, there's actually the ability to discern at the time of request, in some cases, that this looks like a bad domain. It was generated and it looks like it matches some of the heuristics or one of the machine learning models that was developed by these companies, and so they don't have to necessarily have seen it first to make it the designation as malicious. And then the idea is you prevent the person from going to that, or the machine from going to that destination, and you might even point them at something internally, like a sinkhole or a page that says, "Hey, you've got some issues."
You are almost pwned.
Yeah, that's from the most elementary basis. That's kind of what the security products or the DNS security products are doing at a high level. And again, that's become kind of table stakes now. A lot of the major vendors have these, and it's almost like you should be doing this. If you're not doing it, you're probably not catching bad stuff, right? This is just one of the many layers that you could put in place. User education, don't click the link. Malware protections, click the link and something happens, it prevents it from, DNS protection, click the link, it points you somewhere else instead of the bad place that you were going to go otherwise. All these things add up.
I mean, the only thing, the things I would add to that is the age-old concept of split DNS, right? Obviously, if you have the traditional, unless you're a completely cloud-based environment, right? If you have the traditional SaaS offerings, but then you've got your traditional domain type environment, then you want to continue to leverage that kind of split DNS model. Because if that was available with these customers, for example, none of this would have happened for sure. So that's a big one.
Do you want to explain what that means?
Right. Yeah, thank you.
Exactly. So the idea of split DNS is, so let's take, I'll just use insight.com, for example, right? When you're setting up your Active Directory domain names, you could do insight.com, but then the risk that you run there is anytime anyone tries to query that, right? If you're not on the network, guess what? You're getting recursively queried out to the web. So on one hand, you want to start to use the concept of privately named domains so that they don't match your public domain name, right? So that's one of the first things. The second thing is, again, even to support that model, you would have your internal DNS servers serving as, again, they're hosting the zone for your internal domain, right? So you kind of have that, so that hence that split domain. Anything that needs to be queried that's external, those queries go outside to either forwarders or whatever you want to do, right? But anything internal stays on your internal DNS server. So that's really the concept of the split DNS approach. So,
Yeah.
so that's one for sure. And then to Victor's point, obviously, by these protocols now going over more secure connections, it makes any kind of a network level inspection a lot harder. But you can still do inspection at the endpoint, right? Same way you've got endpoint web content filtering before it hits that encryption layer. Some solutions do provide DNS proxy inspection before it hits that encryption layer. And those are great, because obviously it really doesn't matter where you are, on-prem or whatever, the traffic is still inspected right before it hits that encryption layer on your computer. So you certainly want to be looking at those sorts of things. Another thing that comes to mind is, most people don't think about, is typo squatting, right? Registering those domains those typical fat-fingered quote domains, right, that are similar to yours, right? You want to proactively, right? So this gets into the whole proactive measure, start registering those sorts of things, right? So I would say those three kind of coupled with what Victor was talking about, definitely, and obviously the user awareness, especially for IT organizations, IT teams, will drastically reduce the risk exposure there for sure.
You know, Tunde, you mentioned something that I thought we might want to double click on, maybe discuss, because I've heard different schools of thought here, and that is the internal domain having a different fully qualified name internally than externally, right? So like insight.com would be for people who are coming in from the internet to a web presence, versus, you know, insight.local or some kind of internal. And I've heard from customers that are, you know, set up where it's the same and it's causing problems and they want to switch it, and that's a whole night. And I've also heard from folks that swear that it shouldn't be the same, or that it should be the same between external and internal, which seems like a little bit crazy to me. Can you?
So the reason why it's frowned upon is it tends to add a little bit more complication if your internal domain name and your public domain name match, because frankly speaking, you are not authoritative for that domain name on the public sphere, right? It could be GoDaddy or whoever, right? Now, nothing stops you from doing that internally, but then you're going to have to start putting in some rules, right, to make sure that, okay, anyone trying to go to anything, first of all, has to, now you're duplicating records. So it's a lot messier than, and frankly speaking, proper architecture solves this issue.
I'm laughing because I used to have to do that in the past. And, you know, set up DNS entries that point to a hairpin NAT on a firewall because people who are inside want to be able to go to www. And it's hosted internally, and people outside are going to the NAT address on the outside. And I was asking because I knew it was a
it's a mess.
Well, also, it by default, when you create accounts, if you're using that internal namespace, it creates the wrong email addresses for folks. So there's some nuances. You know, you want them to have .com, not .local as their default names, and so there's some nuances. But again, that's where planning and the appropriate architecture is what you need to do. And you got to figure it out. Is it the ease of implementation and using it from this perspective or this perspective? You can secure both of those things. So it's not like this is the only way to secure it, but there are some things that are inherently secure, but more complicated on the front end versus the back end. But we can work with both. And I think that's where, you know, it'd be awesome if there was just one way to do this. There's not. You got to kind of figure it out. And then you've got all these applications that would just not work if you started using a local namespace. And there's a lot of SaaS stuff going on.
Oh, yeah, absolutely. Yeah. So, but hey, it wouldn't be, that's DNS for you. What can we say?
That's pretty much it. Yeah. Mic drop, we're out. Well, guys, I think that's probably a good place to stop. You guys, this was fun. We should do this again. We should pick more topics and just like throw it out here like this, because I had a good time.
Absolutely.
Haikus.
And more haikus. There'll be haiku every time now. And I know, Tunde, you just finished a blog entry that's going up on insightcdct.com that folks can refer to.
Yeah.
And if you want to know more about what we do here at Insight, please visit us at insightcdc.com. And thank you so much for joining us today. And we appreciate all your comments and suggestions. Have a good day. Thanks, guys.
Thanks, everyone.
Cheers.
Goodbye.